Okay. Can you first take some time to read through? We are looking at this is JEB. This is JEB. So read through first and then we start. Okay. Hope now you have finished to read through. So when we break this item, they have told us that an engineering team is transporting equipment to a construction site across a river. The equipment is first pulled up a rough inclined plane with an angle of inclination. Now, the moment you see the word rough, what has to come to your mind? That there is friction force, because any rough surface will always experience the friction force. The coefficient of of friction between P and a plane is 1 out of 8. So this is 1 out of 8. So you could first summarize your diagram. Then they told that the equipment is pulled by a light inextensible string passing over a smooth pulley. A 5 kilogram mass on the incline is connected to a hanging load Q of 4 kilogram. Q is initially 2 meters above the ground. The system is raised from the rest with a string towed. So they want you to investigate the acceleration of the system and the time taken for the hanging mass Q to reach the ground and the distance or mass P moves up the inclined plane. So what are you going to do? You are going to summarize and say the angle of inclination, the angle of inclination for the plane, the angle of inclination which you can call theta. Now from here you know that sine inverse of 3 out of 5 is what is equal to theta. That is your theta. So in order for you to get it, it means you have now sine of theta equaling to 3 out of 5. That is the meaning, or that is the angle. And many cases, when they give you in form of 3 out of 5, always try your best always to calculate in accuracy. So there is no need for you to do. So now here, I can bring it in this form that if this is our angle we have for theta, you know that sine is given by opposite out of hypotenuse. So that means that this is your 3 and this is your 5. So in order for you to be able to get here, you use your Pythagoras theorem that 5 squared minus 3 squared. So 5 squared minus 3 squared will give you a root of 16, which is the 4. So meaning that here you have 4. So in case you encounter any cos of theta, where there is cos, we shall say cos is adjacent, which is 4 out of the hypotenuse. Then we have the coefficient of friction. So that means that your coefficient of friction, which I'm going to call mu, is equal to 1 out of 8. Then what else have they given you? They have given you the mass and they have given you two loads that are being pulled over a smooth pulley. So here we have an inclined plane. An inclined plane is a plane of this nature. But on this inclined plane, you have a load that has been placed there. Which load is P? So you have here a load which is being placed, which is P. This is our load P. And this load is being pulled, However, at the end of this inclined plane, there is a pulley that is smooth. And now it is pulling. It is pulling the what? It's pulling the load. But this pulley that is being attacked is Q. So what does it mean? It means that this load is being pulled up. It is being pulled like that. Now, that is our simple sketch. Kindly let me know whether we are on the same page up to that point. We are just now extracting the information. And they have told that Q is just 2 meters. So here we shall have 2 meters. But I want to first know whether everyone has clicked up to that point. Are we on the same page up to that point? Okay, same page. Good. Now that we are on the same page, allow me now to draw a good sketch on the next page such that we start. Now we have, this is our inclined plane, and we have called this angle to be theta. On the top here, we have our load. This is our load P. And when you look at the question, you'll notice that a 5 kilogram mass on the incline is connected to a hanging load Q of 4. So meaning that this one is 5 kilograms. Then up here, you have a pulley. And then I'm going to come here. And then here, I have a mass, which is 4 kilograms. And this mass here, its distance from where it is up to this ground level, they have told us that it is 2 meters. So this is your mass Q. Now, they have told that this particular force here, this body, there is a frictional force, which I'm going to call Fr. Now, what do you need to do? Put all the forces acting on the body. When a body is here, we are going to have our force, which is the reaction force. But our reaction force, we are going to have the weight. And please, when you look at my weight, our weight acts vertically downwards. So your weight is going to be 5g newtons. But here, when we resolve along this plane, along this line here, we shall have, because if this is theta, also this one is always theta. So this one is going to be 5g cos of theta. Then along this axis here, we are also going to have our component, which is 5g sine of theta. Then when you come here, remember here, from Newton's law of motion, you know that action and reaction are equal and opposite. So this 4 kilogram mass, there is a force. This one being a string. In a string, we have what we call tension force. So the tension is going to act upward. Then where is the action? Then we are going to have another force acting downwards. So at this point, we shall have 4g newtons, because we know that action and reaction are equal and opposite. Now, at this pulley system here, we have our reaction force. So remember, action and reaction are equal. So at this point here, we shall also have the tensional force. Then this side here, we're also going to have the tensional force. But even here, because there is a force pulling downwards, there is another force pulling up, which is still the tension. This one being one string, it means that the tension in the string is the same. So all the tension in the string is going to be our T. So what happens next? Now what happens next is, where is the direction for the body? Because they told us the body is being pulled, it means that our acceleration is going to be pointing this side. So this is going to be our acceleration, A per meter squared. So acceleration is going to take on this direction. This is a meters per second squared. Now, that is how your working diagram is going to look like. Now, after getting the diagram, the next thing you're going to find out, or the next thing you're going to do, is to continue, is to go on and now ask yourself. Now, you start, you know that from Newton's laws of motion, force is equal to ma. So you start working on force by force. Then I'm going to say acting, forces acting on the 5 kilogram body, on the 5 kilogram, or you can say acting on P. When you come at P here, at this point P, what are you noticing? You are noticing that at point P, here you have this force, which is T. You have also these two forces acting. So, and where is the body going? The body is going up. What does it mean? It means that this tension is bigger than the combination of all the two forces. So, what does it mean? It means that now our force, our resultant force R, Fr, is equal to ma. What is Fr? We shall have T minus the forces acting downwards, which is 5g sine of theta, then plus the friction force, which is Fr, is equal to our mass, which is 5 times acceleration, which is a. Because this body is moving up, we shall always have our acceleration. Now, to continue, this is T minus 5g. I can substitute in some of the values. Sine of theta, we know from our diagram that we have been having, we say that sine of theta was given as, to be sure, was given as 3 out of 5. So sine of theta is the same as 3 out of 5. And then the cos of theta was 4 out of 5. So where there is sine theta, you put 3 out of 5. So here we shall have 3 out of 5. Then plus Fr, which is mu r, is equal to 5 of a. So we shall continue and say T minus this 5 and the 5 cancels, so you remain with 3g plus what is your mu? Our mu was given as 1 out of 8. But what is R? So when you look at our R, the only force, we have this R in the vertical position, vertically opposite to down. So it is 5g cos of theta. So our R will equal to 5g times cos of theta. Cos of theta is 4 out of 5. So what shall we end up with? The 5 will cancel, so remain with 4g. So where there is R here, we shall put 4g. Everything is equal to 5a. So by 4, 1 by 4, this is going to be 2. So we shall end up with t minus 3g, then plus g out of 2 is equal to 5 of a. So 3g plus g out of 2, they can be added. So you can have t minus 3 plus our 0.5, which we can write as 3.5g is equal to 5 of a. Now this one, I can first call it our first equation. Then where is the second equation? The second equation, we are going to say now forces acting on Q, or someone can say on the 4 kilogram load. So when you look at it, since this body is moving downwards, because it is the one pulling, it means that this force here is bigger than the tension. So what are we going to come and say? It means that our resultant F of R is equal to ma. So the resultant forces, we shall have 4g minus the tension. This force upwards is equal to m, which is 4 times a. Now, this is our second equation. So what are we going to do? We are going to solve these two equations simultaneously such that we can be in position to get what our t is. So there are two options. Either you make t the subject and you substitute here. So I can do it. So from this equation, you notice that t is the same as 5a plus 3.5g. From this equation here, equation 1. I've taken the 3.5 this side. So when I come here, where there is t, I'll put here. So I'll say now substituting for t from equation from equation 1. So I'll come here and say this is 4g minus our t, which is 5a, plus 3.5g is equal to 4 of a. So you open your brackets, we shall have 4g minus 5 of a. Now this negative also affects here, so we shall say minus 3.5g is equal to 4 of a. So we collect like terms. 4g minus 3.5g, we shall end up with 0.5g, then minus 5 of a is equal to 4a. So we can take the 5a the other side, so we shall have 4a plus the 5 of a. So here we shall have 0.5g is equal to 9 of a. But what is our g? Our g is what? 9.8. So we shall say 0.5 times 9.8. Everything divided by 9 should give us our a. So can you place your calc and confirm that we are getting our answer for our acceleration here? I'm getting my answer as 49 out of 90 is equal to a, which now we can write as 49 divided by 90. I'll get my answer as 0.5444, and these are meters per second squared, and this is equal to our a. Because the item here had required us to investigate the acceleration of the system and the time taken for the hanging mass Q to reach the ground and the distance. So here, this is going to be our acceleration. Members, have we understood up to that point? Allow me to check. Okay, 0.5. Okay. Okay, we are on the same page. Okay. So next, we are going to, one thing I want you to take note is here I want to give, because I know you may ask yourself, how can a 4 kilogram body pull a 5 kilogram? Now, it is very possible. Many times you have seen like in real life, let me use a pulley system. In real life, you have been able to see that when someone is in the let me say they're in the pit. Let me use that. You have seen when someone is in the pit, you will see someone pulling a very heavy thing. Let me say can pull a 50 kilogram body when the person is a 2 kilogram, or let me say is a 30 kilogram person. He can pull it. Why? Because when you are using a pulley, you use less effort. So it does not mean that a 50 kilogram will always pull a 30 kilogram. Because whenever you are using a pulley and you are pulling, remember here they are pulling. When you are pulling, it can come. It does not matter what weight it is. You have seen on those inclined planes, as this pulley makes the work easier. So if someone is pulling, like the question told us that they were pulling, it means that it is very, very possible. So hope that is okay. Helen and Bettina, as we dive into getting the distance. Yes?
Good morning, teacher.
Yes.
On that part where we were resolving the forces on the 5 kilogram mass.
Yes.
So on the third step, when we did T minus into brackets 3g plus 1 over 8 is 4g. Why
Yes.
did we consider 4g as our R?
Our R, no, it came from here. Are you seeing from here? Because this R is directly opposite to this. So we said R is 5g cos of theta, but our cos of theta is 4 out of 5. So by 5 by 5. So we got our R from there.
Okay, thank you.
Okay.
Good morning, sir.
Oh, yes, morning.
So for me, I request for clarification on the forces indicated at the pulley.
So which force?
Like if you go back to our diagram, that's that part of the pulley, the R and everything.
Oh, here.
Yes.
No, like here, what I was trying to show you, let me say this is the person. Whenever you are seated somewhere, there is a force acting downwards. If this is a person, let me say this is a 5 kilogram person. Here there are two forces from Newton's third law of motion that action and reaction are equal and opposite. So whenever you sit somewhere, there is a force that is keeping you where you are for you not to move. So that force comes because action and reaction are equal. So when a body is somewhere, always there is a reaction force. And downwards, there is a force being acting on it. For this case, it can be weight. So when this pulley is in this position, there is reaction on it. But this reaction is composed of this tension and this tension. When this body here, this one, is being pulled up, acceleration means acceleration is the rate of change of velocity with time. Now, the acceleration depends on velocity. Where is the body coming? Where is the body going? So it does not depend on the mass. Acceleration does not depend on the mass of the body. Acceleration depends on the velocity. So if our body is moving this side, this is the direction of the velocity. It is going this side, so your acceleration will point towards where the body is moving. So I saw a comment in the chat. So please, it does not depend on the mass. It depends on the direction where our bodies are moving towards. I don't know
Teacher,
whether Bettina, continue.
is there any case where you may be required to calculate for that force R?
R, yes, I'm going to give you those cases. I'm going to give you those cases.
Okay, thanks.
Okay. Okay, so we are going to continue. Now the next thing they asked you, they wanted us to find the time taken for the hanging mass Q to reach the ground. So what do you need? So they told us that Q is initially means that before it starts moving, it was 2 meters above the ground. The system is released from rest. So if something is released from rest, it means what? Now we come, okay. Let me create some more space here. So since our system is released from rest, what do we need to know? Now, since the system is released from rest, we are going to come and say now, since the system is released from rest, it means that our initial velocity, which is u, is going to be 0 meters per second. Then what next? The distance this particle is going to move, we have already seen that it's going to be 2 meters because they told that when it is at a distance of 2 meters from the ground, so that is going to be 2. Then what else? We need the time. But at what point, at what was it accelerating with? So it was accelerating at 0.5444 meters per second squared. So we shall come from Newton's second law of motion and say S is equal to ut plus a half of at squared. So what was our S? Our S was 2, the distance the particle moved. What was our U? U was 0 times the t plus our half times acceleration, which was 0.54444, then times our t squared. So what are we going to have? We shall have our 2 equaling to a half times the 0.54444 t squared. So what can we do? So when we come here, we can take the 2 this side and we get 4 equaling to 0.54444 t squared. So we divide it throughout. So we have 4 divided by 0.44444 is equal to t squared. So when you divide on your calc, 4 sorry, 4 divided by 0.5, 4, sorry, 4, 4, 4, 4, 4, we end up with an answer like 7.346998751 is equal to t squared. But since we are interested in t, you get the square root on both sides. So what is going to be our t? Our t is going to be 2.7105, and these are going to be our seconds. So that is our time. Now, okay, I'm seeing a hand up. Okay, I'm going to come to you. So that is our time that we do have. Now, after obtaining your time, in case, okay, in case someone doesn't use this approach, which other approach can you use? The second approach someone could use would go in with this approach, u squared minus 2as. Now, if you go in for this approach, what do you need to know? You first find the velocity v with which this particle was hitting the ground, the velocity it had when it was hitting the ground. After finding that velocity with which this body had when it was hitting the ground, then you go on and find the time. How are you going to find the time? Then you go back and get the time basing on that. So someone could use that approach. You get the same things. But also, you need to be very careful with what you are finding out. Okay. So, but the best one, we could use this one that goes directly, such that we know what we are getting. Sorry, this is a plus. V squared is equal to u squared plus 2as. Okay. Yeah. Okay. I'm seeing a hand up. Let me come and pick you. Let me come and pick your hand. Uh, okay, so maybe those who are using this approach, you first get the velocity with which the particle had after the 2 meters. So that is going to be v squared. Initial was 0 plus u2 times a, which is 0.54444, then times s, which was 2. So you get v squared is equal to, when you multiply that, 2 times 0.54444, then times 2, you end up with 2.7776. So when you get the root, our V will equal to 1.47572. Now, this is the velocity the particle had, the final velocity when it was reaching the ground. Then from there, we shall come and say now V is equal to U plus AT. So your V here is going to be 1.47572 is equal to U, which was 0, then plus acceleration, which was 0.5444, then times the time. So you end up with 1.47572 divided by 0.54444 is equal to the time. So when you divide, you'll get the same answer. So here still you'll get 2.7105 seconds, which is equal to time. So you could use any of the approaches. Members, let me know whether we are on the same page. Bruce and then Rocky.
Excuse me, Chair.
Yes.
Good morning, Chair.
Yes, good morning.
So, Chair, for me, my question is about this formula of S is equal to UT plus a half AT squared.
Yes.
Chair, when do we use a minus?
Oh, now the minus, we use it when it is acceleration due to gravity. And when it is acceleration due to gravity, we use it when a particle is moving upwards.
Oh, okay. Thank you.
We use it for acceleration due to gravity. We use it when a particle is moving upwards. That's the only. Maybe another case where we can use a minus when it is a deceleration.
Okay. Okay.
Yeah.
Thank you.
Okay. Yes, I can do now. I can do now. Okay, I failed to get a can now. Then the last bit of it, let me ask you. They said, to reach and the distance mass p moves up the inclined plane. So members, you tell me, what distance does mass p move up the inclined plane? What do you think is that? The distance. The distance must be moves up the inclined plane. Okay? Remember, when the other body is moving, it is also moving. As the other body is moving, it is also moving. So, very good. So it should be the same because if this one moves 2 meters, it is also going to move 2 meters. So for this case, your distance, the distance moved by P, distance moved by P is also going to be 2 meters because as this one is moving, also the other one is moving. Okay, hope that is okay. Kindly let me know whether we are on the same page. Kindly let me know whether we are on the same page. Are we good to continue? Has everyone understood that? Okay, same page, same page. Okay. But if you calculate, you will get the same answer. Even if someone had calculated, would have gotten the same answer. Let me say someone calculates. Let me say you have calculated. You'll have still S is equal to UT plus a half of AT squared. So you'll find your time S is equal to a half. Initial was 0, so it will be a half times 0.54444, then times the 2.710 squared. You'll get your answer as 2.2 as well. But since you have decimal points, your answer will be not so accurate. But still, when you calculate, you'll find yourself getting the same answer. Okay. Hope that is okay. I'm seeing a hand up. Let me pick that one hand. Julie?
Morning, sir.
Yes, good morning.
Like I'm asking, what if you're given a question that when the mass P moves, then the spring breaks. Find its final velocity. Is the final
Ah,
velocity for P the same as for Q?
no, they may not move at the same velocity depending. If one breaks, let me say, like here, you are saying at this point, like
Yes.
if one of them breaks off,
Yes.
Now, if it breaks off, the velocity for in practicability, if this thing breaks, the velocity of this and this one are going to be different. Why? Now, because this one is going to come down, but here when it is coming down, because there was frictional force and this is a rough surface, its speed is lower or it is lower compared to this one. So this one moves faster compared to this.
Okay.
Okay. Okay, so
Thank
members, allow me now to first continue. Now, for this particular item still, like I showed you, they could ask you to find the reaction force. Now, I want us to summarize things concerning reaction. Now, when it comes to reaction in pulleys, we have different cases, and I'm going to show you all the cases. The first case is when you have a pulley. Let me say this is our pulley that is hanging. You have this pulley here that is hanging, and this is here you have this side. Like I've said that always on a pulley, for this pulley of this nature, reaction is going to be up here. Now, if that is your reaction, this reaction it must have other forces opposite to it. So the forces we are going to have here, we are going to have T here, we shall have T here. Why T? Because the forces must be always equal and opposite. So here, action and reaction are equal and opposite. Now, for such a case, what does it mean? It means that our reaction force R is equal to the two forces acting downwards. So which is T plus T. So our R is going to be 2T. Now, whenever you have a pulley of this nature, to obtain your reaction will equal to 2T. That is one case. What is the other case? Now, there are cases where you're going to have your pulley system of this nature, whereby at this point here, you have your pulley. Let me say this is a pulley. And this pulley has a reaction here, has tension there. It also has tension at that point. Now, at this point here, where does your reaction act? Your reaction always acts in this direction. That is the reaction force that keeps that pulley in that position. Now, what happens is that the angle you have at this point, that is 90 degrees. Now, when you look at our R, I can extrapolate it like that. I can bring it in that format such that you can be able to understand it very, very well. But when I bring it in that format, I want you to understand one thing, that this tension is like, to be able to understand, let me put it here, that this is the tension. This T, assume it is somewhere here, and also this T, assume that it is somewhere here. Now, to be able to find the forces opposite to this reaction, we are going to resolve and have this T resolved towards this. But this one being 90, this is 45, and this is 45. So when you resolve this T towards this, you are going to end up with T cos of 45. For this first one here, when you resolve this one also towards here, you end up with T cos of 45. Kindly, can you let me know through the chat whether that point is okay? Kindly let me know whether that is okay. Is that fine? That point? It is okay. Very good. Now, people who are not getting it, I want you to just imagine something like this. You have something like this, that this is where your T is, and this is where the 45 is. So for you to resolve it towards this side, you have to bring it this side. So this is your hypotenuse. This is the opposite. This is the hypotenuse, and this is the adjacent. What are you interested in? You are interested in which one? You are interested in getting the hypotenuse, but you have adjacent, so you say cos of 45 is equal to adjacent, which is T, out of the hypotenuse, which you don't know, hypotenuse, something like that. So when you resolve it towards this side, that's how you end up with our cos. Hope that is very. So here at this point here, we shall have the cos. Now, what do you need? What do you need? Now you'll find out that our reaction R, what is it going to equal to? So our R is going to be these two forces. This R, are you seeing this? R is going to equal to these forces, because when you resolve, you note that this one is pointing this side. You note that this one is also pointing this side. So your R is going to equal to, here we shall have our T cos of 45 plus the T cos of 45. So your reaction is always equal to 2t cos of 45. In case your pulley system is in that form. In case that is another case. Another case that you may meet is when you have something like this. You may meet a case of this nature, something like this, whereby now you have a pulley at this point. If you meet a pulley at that point, let me say this is a pulley, you may have your reaction here. And let me say this is your T, and this side, this is your T. Now allow me to divide this, that maybe this is your angle theta and this is your angle theta. Now for this case still, you come here, resolve. So you get T cos of theta. This side, you resolve, you get T cos of theta. You get the angle in between these two. So that means that for this case, your R will equal to 2T cos of theta. Now, what about for this particular case we have? Now, in case, let me use this now. In case this is the kind of thing you have, what happens that here, the angle you have, many times they give you this angle. And at this point, you have 90. So which angle do you need? I'm going to first find out the angle I have at that point. So I can say theta plus 90 plus this angle, which I'm going to first call x, plus x should give me 180. So what shall I have? I take the 90 this side, I'll have theta plus x is equal to 90. So I want x is going to be equal to 90 minus my theta. Now, if I have 90 minus theta, remember this is going to be your pulley system. Reaction is going to act in this side. So what do you need to do? I'll come here. Are you seeing? Now, if this angle is 90 minus theta, and this reaction I've divided into equal parts, now the angle I have here is going to be divided into two equal parts. So you'll have 90 minus theta divided by 2. So here you'll have 90 minus theta divided by 2. Also this side you have 90 minus theta out of 2. So remember, your tension is acting here, your tension is acting somewhere here. So when you resolve it towards here, you'll get your T cos of 90 minus theta out of 2. This side you'll get 90 minus theta out of 2. So what do you end up with? You'll get your R equals to 2T cos of 90 minus theta out of 2. So that is going to be your reaction in case your pulley is in that form. Kindly let me know through the chat whether we are on the same page. Okay, let me pick a hand from Calvin and then Engineer.
Thank you, sir. Good morning, sir.
Yes, good morning.
Yeah, for me, what I was kindly requesting that as you have summarized for us the one for reaction, because at the time we face challenge when you are getting acceleration, when you are given like two pulleys, like there are times when the acceleration changes, when it becomes like a half. Yeah,
okay.
a half. Then I don't know when really to use. Or you add the two accelerations, then you divide them by 2. That confuses me. I don't know how to do it best.
Okay. Calvin, you are going to allow me to handle that in tomorrow's session when I've come with scenarios, when we have two pulleys.
Oh, okay, sir.
Okay. Okay. Engineer, but I'll talk about it tomorrow. Engineer?
Good morning, Master.
Yes, good morning.
Master, I'm confused here on that pulley, the second one. This one, which...
This one?
No, this
one?
one. Yes, that one. Master, we always resolve to perpendicular and horizontal. But now I thought that now that would be like the resultant.
Oh, no, now when we are resolving, it's not that always it is what? Horizontal and vertically. You can also resolve along the hypotenuse. What you are interested in is bringing this T towards here. This is what you are interested in because this reaction is acting at an angle. This reaction here is acting at an angle. And you know reaction and action are equal and opposite. So which forces are acting on it? It is this T. So that's why you have to bring it towards here. Then this T, you have to bring it towards that point. So that's what we are trying to do.
Now, Master, what if I get what if I try to get the hypotenuse using Pythagoras theorem?
Hypotenuse?
Yes, when using Pythagoras theorem.
But still now there's no, because what you have is like here, you have T, and you have an angle here, 40, 45. So there is no way you can get this using Pythagoras theorem because you don't have this X. Let me say this is your X, and also you don't have this. Let me call it Z.
What of that T that is horizontal?
Which one? Now this T that is horizontal here, this one here. Remember,
Yes.
this is another force, and also this is much as they're the same forces. So here you want to get because if you are to use that approach, that is going to be, let me first, that is what, 2, that is T squared. You'll end up with T squareds, which is not true. Because if you bring this and you use your Pythagoras, here you are going to get the hypotenuse, but in squared.
Okay, Master.
So that approach may not work, but learn that when you are resolving, it's not that always must be vertically or horizontally. You can also resolve something at any angle, diagonally or any, as long as it has been given to you.
Now, Master, does it depend on what force you want to get?
Yes, it depends on what force you want to get. In case you want to get here, it depends on that. Okay. I think let me pick just one more from Liz and then we continue.
There is a question, Steve.
Yes, please.
Master.
I'm coming back here. Members, can you go on and find for me what is our reaction for this pulley? Use the knowledge we have done. Use the knowledge I have given you here. Can you get the reaction for this pulley we have been dealing with? Here, get for me the reaction. Liz?
All right. Teacher, good morning.
Morning.
I was confused about this other part of the third case where we had 90 minus theta. Would you please explain more?
Now, for the third part here, we are going to use the number we have been doing. When you look at that third part, you have, I'm using the number we have been doing. So when you look at it, it is like this. Now, many cases, when you are dealing with the inclined plane, they give you this angle theta. Now, for our case, they gave us sine theta equals to 3 out of 5. That is what they gave us. Now, remember this angle here is 90. So in case you have this as your pulley, in case this is your pulley, let me say this is R. Remember this one is vertically like that, it is opposite. So the angle you have at this point here, it is always divided into 2. So this is 1/2 and this is 1/2. So in order for you to get this angle, let me say for this case it was 3 out of 5, like the way they gave us. It means that here our angle theta is equal to 36.87 degrees. So here you have 36.87 degrees. So to get the angle at this corner, you will get 90 plus this, then minus 180. So you say 180 minus 36.87, then plus 90. So you end up with an angle. The whole of this angle here is 53.13. But since you want this middle here, you'll say 53.13 0.13 divided by 2 because they have divided it into two equal parts. So this one here is going to be 26.565. Also, this one is going to be 26.565. So what are you going to do? Now, once you are resolving this TD side and the TD side, so there you will say your R is equal to 2. Okay. Now here I'm giving you some. R will be T cos of 26.565 plus your T cos of 26.565. So which is the same as 2T cos of 26.565. I don't know whether you have got it.
Yeah.
Yes. So that's why we
Teacher,
apply
thank
the
you.
arm. Okay.
Okay.
So members, you can get your reaction. Sometimes they may ask you for the reaction, meaning that you need to know how to obtain the reaction force. Members, are we good to continue now? Let me know. Are we good to continue? Reaction. Reaction 66. I don't know why some are getting 66. What was your tension? Okay, reaction is 66. Good. 66, I think that's what people are getting. Okay, so we are going to continue. So, but I expect you to first obtain the tension. Remember here, you needed to obtain the tension first before you proceed. So your tension here, allow me to just confirm such that I know your answers are okay. Minus 4 times 0.54444. So my tension, I've got 37. Mine was 37 here. So when I said 2 times 37.0222, hope I did not make any mistake. So you get something like that. And always here, since we are dealing in degrees, yes. So this is cos of 26.565. So I'm getting 66.2274. Yeah. And what are the units? These are newtons. Okay. So that is how you work that particular part. Then we go to the next part. Now, the next part we have, they have given us our forces acting on an object. So what do we have? They have told us that at the top of the incline, 4 guide cables exert forces of 4 Newton, 5 Newton, 9 Newton, and 6 along ABCB eta, where ABCD is a rectangle. So what you do here, always first come up with a sketch. Whenever you are dealing with mechanics, it is better you come up with a sketch. So you come up with a sketch and always follow when they say A, B, C, D, you start very well. You can start from A here, then you have B this side. Or you can have A, B here, and then it is okay for you, whatever thing you want. So I'm going to have A, B here. I'm going to have my C here, and I'm going to have my D here. So what have they told us? Where ABCD is a rectangle and AB is equal to 2AD. So that is what we have now. So what are we going to do? What are we going to do? So what we do always, they have told us that A to B is equal to AB is 2A of D. A to B. A to B is twice AD. So what does it mean? In case this is A to B is 1, then this one is going to be 2. AB is twice AD. So in case, let me now just and say that let A to D equals to X. So if the distance, I'm going to use distance that let the distance A to D be X. So from here up to here is where I'm calling my X. What does it mean? It means that my A, I've called this one. So this is your AD, is what I'm calling X. So it means that my A to B is going to be twice of X. So here you'll have twice of X. If you don't want, you could use it the way it is. Now, what this is now your distance. What do you need to know? You need to know that those distances are going to be very key when you are obtaining the what? The angles. They're going to be very, very, very key when you are obtaining the angles. But it is not bad. If you wanted to call this to be 2, it is okay. You'll get the same answer. So now we are going to start. Along AB, you have 4 newtons. So here, you're going to have your 4 Newton force. Along CB, what is CB? Look at the letters C to B. So have that arrow is 5 Newton. A to D. A to D is here, and here you have your 9 Newton. Then A to C. A is here and C is here. Put the arrow. And this one is 6 root of 2 newtons. What are you interested in? You are interested in finding out which angle you have here. So this angle, I can call it theta. So in order for me to get theta, I'm going to use the distances or the relationships I have. So someone could say, it depends on what you want. Someone could say that tan of theta is equal to opposite. What is my opposite? My opposite was C to B. Divide by my adjacent, which is distance A to B. So someone could come and say this is tan theta equals, but this one being a rectangle, this one being what? A rectangle. This side AD is equal to CB. So here someone could put that this is AD out of A to B. When you continue, you could say that this is tan theta is equal to, what is AD? A to D. AB from this relation is 2AD. So here you can have 2 of A to D. So meaning that your tan of theta will equal to 1 out of 2. And therefore, you can go on and get your tan. So meaning that your theta will equal to tan inverse of 1 out of 2. And tan inverse of 1 out of 2, when you place your calc, you end up with 26.565 degrees, or which you can approximate to 2 decimal places as 26.57 degrees. If you have not used that approach to get the angle, then you can use this approach here. So if you are to use this approach, but I would recommend a lot this one, but if you are to use this approach, still you get the same. You say tan theta is equal to my opposite. We have called this one x, divided by the adjacent, which is 2x. So the x cancels, so still remain with tan theta equaling to a half, and therefore your theta will equal to tan inverse of a half. So tan inverse of a half still gives you 26.565 degrees. And then to 2 decimal places, it becomes that. Members, are we on the same page? Are we on the same page? Julie asked, are we on the same page?
Like teacher, I'm confused the way you're letting, because AB is equal to twice AD. I thought that now since you've made AD to be X, so now AB should be a half of AD.
From here, we have
Yes.
said A to B is equal to 2. You have said AD is X.
Yes.
So you fill in. So meaning AB is twice X.
Okay, thank you.
Now, Liz, unless for you what you have done, you have said that let A to B be X. If that's what you have done, then you'll come and say AB is X equals to twice A to D. So you divide by 2, divide by 2. So you get X out of 2 is equal to AD. So that one is also very correct. In case this one you have let it X, then this will be X out of 2. So still you get the same answer.
Okay.
Okay. Okay, so from the chat, members are telling me that yes, we are on the same page. So, let's now proceed. Now, when we are, okay. So we are going to continue now that we have got our angle. So allow me now to write it here in a very good way, in a better way. This angle we have got is 26.57 degrees, and which forces, allow me to put that this is our A, This is B, C, D, which forces 4, 5. So here we have our 4 Newton, 5. We had our 5 Newton. We had this force. We had 9 going up. This was 9 going up. And then we had 6 root of 2 newtons. So now we are going to find forces along the x and forces along the y. But if we want, I think this time round, let me use 1. So I can say that let the resultant force, which I'm calling R, equals to F along the x and F along the y. So our forces, today I'm going to use vectors, but feel free to use what you are interested in. But like I guided yesterday, that it is okay for you to use whatever thing you do, but always I advise you resolve separately. So allow me to stick to that, but those who want for using vectors, please continue. So I'm going to say my forces along the horizontal. So which I'm calling f of x. So along fx, I have this one, which is going to be 4. Then this one is not considered. I look at this. So when I resolve that, it will be 6 root of 2 cos of 26.57. And then when I look at that, that one is not going to make any contribution. So my forces along the x, I'm going to have that. So I'm going to come and say cos of 26.57 times 6 root of 2, then plus 4. So here we shall end up with 11.5891, and these are newtons. Then I say forces along the x, along the vertical, or along the y, sorry. So along the y, I will call them f of y. So along the y, I have this force, but it is pointing downwards, so I write it as -5. Then this 9 is pointing upwards. I write it as a +9. Then you resolve this force towards the vertical axis. So when you resolve it, it's going to be pointing up. So it will be 6 root of 2 sine of 26.57. So when you get the answer, okay, you compute, and please confirm that our answers are the same. In case they are not the same, then we check through what the error is in our answers. Okay, so our f of y will equal to 7.79539 newtons. Kindly confirm that our answers are the same for x and y. Those who are using this approach, let me put all. Those who are using this approach, for your f, it will be 4 and 0, plus when you go to 5, it's going to be 0 and -5, plus those who are 9, it's going to be 0 and 9, plus when it comes to this, it's going to be 6 root of 2 cos of 26.57 and 6 root of 2 sine of 26.57. Those who are using the vector approach. So members, is the answer the same? Do we have the same answers? The same answers, same answers. Okay. Arnold, you can unmute.
Good morning, sir.
Yes, good morning.
Teacher, I was inquiring on the part when you are allocating the vertical for 9 newtons.
Yes.
Do I take the aspect that is 9? It's going to be 9 sine 90.
Oh, when you are resolving vertically?
Yes.
Okay. Yeah, because, yes, that is true. It is okay.
But how does it come about?
Now, what you are doing, you are saying this 9, eh?
Yes.
And remember, this is 90.
Yes.
So what you want to resolve it vertically. Now, if a force
Yes.
is already along the vertical, there is no need for you to resolve it, as long as it's along the vertical and the horizontal. The angle already in between is 90 degrees.
Yes.
Unless when you wanted to take it along the what? Along the horizontal. If you wanted to take it along the horizontal, let me say here, it becomes 9 cos of 90. But 9 cos of 90 is 0. So that's why that component is 0.
Yes. So the 9 cos of 90 would be 0, and that would be for the horizontal.
Yes, that would be for horizontal. Because it does not have it does not have a horizontal component. It only has a vertical component.
Yes. Thank you, sir.
Okay. Yes. Members, continue and get your resultant as I pick one hand from Mr. Short. Mr. Short?
Good morning, teacher.
Morning.
What about when you consider point C, not A?
When you consider point
C.
C.
Yes.
Now, because they gave us A to C, when you consider point C in terms of what? Maybe you need first make me understand.
Like for resolving this process. Will I be on the right track, or I'll deviate away
When
from the
you
question?
consider point C,
Yeah.
what are you considering point C for? That's what I want to know first.
Because like when I take this angle, is what like they are
Make me
alternating angles.
understand.
Me, so when I consider point C, the angle 26.57 will be alternating with that.
Consider here.
Come again?
So what are you solving? What are you resolving? What are you resolving?
The process.
Yeah, if you want, you could put it there. Then when you are resolving this, it will be here. When you are resolving the 6 root 2, still it will give you 6 root of 2 cos of 26.57.
Okay,
I
thank
don't
you.
know. Okay. Members, let's continue. Let's continue. Now, to get our resultant first, and always I encourage you draw, use sketch, such that at least you know, because sometimes you don't know what can happen. So use sketch, make a simple sketch that this is positive, is where you start from. So your y is 7, 9, 5, 3. That is the first one. A minute. Okay, so this is 11.5891 newtons, and this is, so what is your resultant? Your resultant is here. Resultant means from the starting point to the end point. So this is your resultant, and this is your angle for the resultant. Let me call it maybe alpha. So what am I going to find? I will say that my resultant, you can write, is equal to f of x squared plus f of y squared. So here, our resultant R is going to be 11.5891 squared, then plus 7.79539, and then squared. So can we do our squaring here? When you do your squaring, 11.5891 squared plus 7.79539 squared I'm getting here root of 195.0753. So go on and get the square root. So we end up with 13.9669. That's what I'm getting for our resultant. Confirm that also you are getting that. Then I want to go back. They told us the engineers wish to replace these four forces with a single equivalent force. Now that is the single equivalent force. However, because they have told you a force means a force is a vector quantity. So that means that when you are giving, you do not only give the resultant, but also give the direction it's going to take on. So now R is equal to our f of y. For this case, this is our f of y, and this is f of x. So we shall have 7.79539 divided by 11.5891. So meaning that your tan is going to be tan inverse of 7.7939 divided by 11 point direction. Theta will equal to, when you divide the two, 7.79539 divided by 11.5891. So tan inverse of that, I'm getting 33.93 degrees. So then you are going to conclude and say that the single equivalent force is 13.9669 newtons in the direction of 33.93 above the positive horizontal. Someone could say in the direction, maybe you can say north degrees, north degrees, 50 degrees east. Someone can use that approach. But you give the direction because this is a vector quantity. Direction is very important. Direction is very important. Don't only give the magnitude, but go on and give the direction for our force. So that is what I want to emphasize at that point. So in can take on that question. Let me ask. Yes, Taiwa ask, Baswali and Mr. Short.
Yes, good morning, mister.
Yes, good morning.
My question is that after getting the angle, how do we know that the direction we are having, for example, is north, or is it an eastern direction or any other direction? How do we know?
Now, after, are you seeing what I'm doing?
Yes.
Now, after you have come up with your sketch, let me say this is the sketch. Now,
Yes.
this is your north, this is going to be your east, this is the south, and this is the west. Now, when you are giving directions, always we measure them from the north. That's why I'm telling you it is better to come up with a sketch. Now, the angle you have obtained is the angle here, 33.93. But when I'm giving direction, I can give this direction here. So what am I going to do? I will say 90 minus 33.3, which is 56.07. Now, when I'm giving a bearing, I will start from north, 56.07 degrees towards the east, because that is where your resultant is acting. Alternatively, when you look at the axis, this is x-axis, this is y-axis. When you look at it, this is the positive x-axis, and it is above. So depending on the book you are reading, they can tell you that your direction, you can give it that my direction is 33.93 degrees above the positive horizontal. Now, next time you may meet another case where you have got your sketch. Let me sketches whereby your force along the x, let me say it is 2, and F along the y is -3. Now that sketch will look like this. You move 2 steps towards the right and 3 steps down. Meaning that when you get your angle is going to be here. Now, if you are giving the direction, you could say this angle you have obtained below the positive horizontal. Alternatively, you could come and get this angle here. Are you seeing that angle? Now, if you are to get that angle, for this case, it's going to be 3 divided by 2 tan of that. So this angle we have got here is 56.3. But you add on this 90, so it becomes 56 plus that plus 90. So here you give your direction as 146.31 degrees. Hope you have got the difference.
Okay, thank you.
Yes. And when it comes to 3 in bearings, when it comes to 3 figures, you don't put now those in north, those ones you don't. Put northeast,
Okay.
what? We only include them for angles below 90 degrees. Okay. Mr. Short?
Teacher,
Yes.
basing on the language in the scenario, we say, okay, it was saying that A to B, it was twice A, D. Now, we made A, B to be unknown. So are we going to solve for X, or we shall just leave it like that?
Now, here I've given you 2 options. Are you seeing the 2 options?
Yes.
Yes, I've given you here when I've used exactly what I have in the scenario without letting. And you don't need X. X is distance. So you don't need it unless they have asked you to find it.
It's all right.
Unless they have asked, and you don't need it here. Because we are not going to take what? Moments. Okay, yes. Next.
Teacher.
Yes.
Everything is okay, but your screen is kind of breaking.
Oh, would it be the network? Is it now there?
Yes, it is there.
Okay.
Thank you.
Okay. So now we continue. Now, the next part we are going to look at, it's going to be, allow me to first summarize a bit of it. The next part we are going to look at has a component of crossing the river. That is what we are going to be looking at. Crossing a river. And allow me to first give a simple summary about crossing a river. Now, when you are crossing a river, the choice is yours. Whether you are going to take upstream or to take downstream. Now, what does it mean? We know that rivers flow from, I don't know now that geography, but from up towards down. Like when water is flowing, it flows from up towards the what? In downwards, because water can't flow up. So it always flows from the high points towards the lower points. Now, when it comes to crossing a river, there are basically 3 cases. Number 1 is what we call the shortest. What's the spelling of short? The shortest route you can use. The shortest route, or what we call the distance. Case number 2 is what we call the quickest. Quickest, we can call it the shortest time possible. Shortest time. Then case number 3 is when you want to reach to a point, to a particular point on the bank. Those are the 3 cases we have when it comes to crossing a river. Now, when you are crossing a river always we consider parallel banks. This one we call it a bank, and this one we call it a bank. Now, when we are crossing the river, we call them parallel banks. Now, if you have a person at this point, let me say this is point A, and this is point B, and you want to cross this river from point A to point B, you have 2 options to take. Because remember, a river flows at a very high speed. Now, in case this is the flow of the river, what happens that this part, if this is our line between A and B, this part here is what we call the upstream. Then this side where it is going, we call it the downstream. Now, if you want to cross this river using the shortest route, or using the shortest route, you need to ask yourself, which route am I going to take? That is the first question you are going to ask. So, So if you are to reach this using the shortest route, what does it mean? It means that you must take your course upstream. So when you take your course upstream this side, what does it mean? It means that now the river is going to push you towards this side. Like water, you are going to move in the same direction with water. If you want to take the quickest time, then it means that you will use the downstream approach. Now, we are going to look at a summary of the two. Now, when we are looking at the summary of the two, one, I'm starting with the shortest route. Now, when it comes to the shortest route, like I've said, I'm going to have my parallel banks. This is my point A, and this is my point B. Now, for the shortest route, let me say this is the velocity of water. This is the velocity of the water. And let me assume you are using a boat to cross the river. You are not swimming. You are not swimming. So if I'm to use a river, then it means that I'm going to come like this. Then when I'm coming like this is the velocity of your boat. So the river is going to push you, like this, up to when you reach the crossing. So what do I want to bring to your attention? This one is going to be the velocity of the water at that point. Then they can ask two things. They can ask the course. When we are giving the course or when you are finding the course, always we measure the angle from the bank. This angle here, which we can call what? Theta. We measure it with respect to the bank. Now, number two, as you deal with this kind of approach, you need to know what is the resultant velocity. Like I've said, that resultant velocity means that velocity that combines the two. So it means that my resultant velocity is going to be here. So you are going to have something like this. You are going to have something like this. This is your boat. And now here, they are pushing you the water. And then you are going to have something like this. Now, this one is going to be your resultant velocity. So for it, and then this one is our distance. Sometimes you can call it AB or I can call it my D. So this one is the angle or is what we call the course along the bank. Now, in case I want, in case I'm interested in obtaining one, what do I want? In case I'm interested in getting this resultant velocity V, what am I going to do? I'm going to use my knowledge of Pythagoras. So it means that V squared plus V, this is the river, or let me call it water. V of water squared must equal to V of the body squared. Since I want my resultant velocity, this one, V squared, will equal to VB squared minus V3 squared, meaning that your resultant is always given by the velocity of the boat minus the velocity of the water squared. Members, are we on the same page for that? Kindly let me know. Are we on the same page? Okay, some people here. Okay, I want to repeat the last time that when you are walking or when you are crossing any river, let me say you want to cross from point A towards point B, and the water is flowing towards this side. This is the velocity of the water. And you want to cross using the shortest distance. What does it mean? You are going to come like this. So as you come like this water is going to push you like this. Now, this is the velocity of the water, and this is the velocity of the boat. Now, once it pushes you, you're going to be able to reach your destination. Now, this is what we call the resultant. Now, this is a right-angled triangle. This is a right-angled triangle. So now you utilize your knowledge of Pythagoras theorem. Now, still on the same number here, they can ask you to obtain the time taken. Now, if I'm finding the time taken to cross from point A to point B, what do I do? Time taken, still you use distance is equal to speed times time. So time taken is going to be the distance divided by our our speed. Now, for this case, dear friends, always I want you to take into direction that the distance you want is this d, which is a to b. That is the distance. But what speed? You always look out for that speed with the distance you want to cross. The distance we want to cross is here. Now, what speed is along that is this speed here. So for that case, here we shall divide by v. So we divide by this resultant because this is the distance we want to cross. And what speed is this one, which is v. So here you say d divided by your v. Hope that one is very, very okay. In case, what else can they ask you? In case you want to obtain theta, when you look at our diagram, our diagram is like this, whereby this is the velocity of the boat. This is our velocity of the water. And this is our theta. Now, in case you want to obtain our angle, you want to obtain the angle theta to the bank, what do you need to do? You could first obtain this angle here if you want. Are you seeing this angle here? This angle here. When you look at it, you could use this velocity here. Or alternative, if I don't use that approach, you could come like this. Let me use this approach. When you look at it, this angle is theta, but that angle is vertically opposite to this angle, which is theta. So you know very well that if this is theta, this is your adjacent, and this is your hypotenuse. So what can we use? You can use cos of theta is equal to adjacent, which is the velocity of water, divided by hypotenuse, which is the velocity of the boat. Now, that's how you can get the course at which you can steer such that you use the shortest route. So sometimes if they don't call it the velocity of the water, they can call it the current velocity. Members, let me know through the chat. Are we on the same page now? Okay, that is the first case. Patricia, you could ask. This is the first case for the shortest route. Now I want to do the second part.
So I have a question.
Yes.
On the thing of the shortest distance and the shortest route and the quickest time. I wanted to know the difference.
Oh, now I'm coming to the quickest time.
So for shortest distance, you take the boat so that it takes you in a straight line.
Yes. So you take this route, then water pushes you back. So you move in the direction of the water. So the water will push you back. Now, when it comes to the quickest, or what we call the shortest, crossing the river in the shortest time possible. Now here, what do we do? Let me say this is our river that is flowing. This is the where the river comes from is the upstream. Then this is our A and this is the B. So we want to cross from A to B. What do you do? For you, what you do, come and go in the direction of the river like that. So this is the path that you are going to use for that case. Okay. Sorry, let me put it here. So I want to put it here. These are the banks. This is your A and this is your B. Now you want to cross in the quickest, using the quickest time. So for you, what you do, you are going to say, let me come like this. This is your boat. Now what happens that water is going to push like this. Because you are not going to be able to cross like this. It is impossible. You can't. I think, I don't know whether people know that it is very hard for you to cross the river like this. What happens? The water is going to push you. Now, when the water pushes you, you are going to come this side. and this one is going to be now your resultant velocity. That as you are trying to come and oppose the water, water pushes you. So you are going to find yourself that you are going to reach the destination, but the water would have pushed you quickly, because as you are trying to move like this, I think there is a video even I saw somewhere whereby two people were trying to cross the river. So as you are trying to cross like this directly, the river will push you back. So the water is going to push you, and this is going to be your resultant velocity. Now, what angle? This is the angle that you stay at. Now, what is going to happen? What is going to happen? What is going to happen is that this angle and this angle are going to be vertically opposite. So what do you need? In case I want to find, here they can ask you to find a course. That is number one. Number two, they can ask you to find a direction. Number three, they can ask you to find a distance. So here, what do you need to do? Since this is our resultant V, we shall say V squared is equal to V of your boat plus the V of the water. So what shall we end up with? We shall end up with maybe VB squared plus VW squared. So what next? Now, what next is in case they have asked you for the direction. So when I want this to get theta, I can have this and I can have this. So I can say tan of theta is equal to opposite, which is VB, divided by adjacent, which is that. Now, when it comes to the distance, when it comes to obtaining, let me say you want to obtain the distance and the rest of that, what do you need to know is that for your intention was to come here at B, but the river has pushed you up to point C to reach the bank. Now, in case this is my distance, let me call this one to be maybe D2, and I call this one D1. Now, in case that is the case, I can as well obtain my distance, because this angle here is also theta. So that one still, in case they have given you distance, you can use that approach, that distance is opposite out of adjacent. Now, what are you noticing? That the angle and the two angles are the same. So this relation can be very important. VB out of V water is equal to D2 out of D1. So that relation can be utilized. So in case you want now to find A to B, this distance, because they can also hide AB, you can as well find it. So that is what you can use in case you want. Now, in case they want you to find the quickest time, like you know that time is given by what? Is given by distance out of the speed. Now, what do you need to know here? You need to know that to be able to obtain the distance is this one here. Are you seeing this distance here? This is the distance you use. Now, from here up to here is the distance you are going to use. So in case, let me put here C. It's going to be A to C divided by the speed. Which speed do we have along here? It is V, and that is your time. How do you get SC? SC can be got by D2 and D1. So SC, you can get it by getting the square root of D1 squared plus D2 squared. So that is how you get for that particular case. Members, I don't know whether we're on the same page or not. Kindly let me know whether we are on the same page. Okay, now those are some of the cases they can ask you when it comes to crossing the river. Then sometimes they can also give you that case when the river, maybe when they want you to reach at a given point. So you try out in your free time. The third case happens when they have given you, when they want you to reach at a given point. Let me say they have specified that we want you to reach somewhere at point B. So there is also that case. So allow me now that we go to part C. Now our part C here, that was our part C. So when you look at our part C, what does it tell us? Part C tells us that after unloading the equipment, the team crosses a river which is 50 meters wide, So I'm going to come and I make my sketch. So they told that after unloading, the team crosses the river 50 meters wide. This is our river, which is 50 meters wide, flowing at a constant speed of 3 meters per second. That is what we call current, water current. We can call it the velocity of the water. Now, flowing at a constant. So I'm going to come here and I say V of the water is going to be 3 meters per second. Their boat has a speed of this in still water. Still water is that water that is a bit calm. That is the still water. So the velocity, I'm going to call it the velocity of the boat, is 2.5 meters per second. In still water, the boat leaves a point on one bank. Let me say this is our point A and this is our point B. So the boat leaves a point on one bank to reach a point 35 meters downstream from its starting point. The crew had 2 possible courses in crossing the river, and the best would be where the least time is taken. So, members, let me know through the chat. Yes. What do you think? Let me say you are crossing the river. And this was their assumption that it would be, okay, I have a hand. Yes, Ibrahim. And, okay. Klaus Chome, unmute.
Yeah, good morning, teacher.
Good morning.
Good morning. Yeah, so my question was, before we came to this question, according to the other analysis we made, we realized that for us to always find the time, we always use the resultant velocity. Is it the case?
Oh, for the time. Here?
Whenever we are finding time, we should always have the resultant velocity. Is it the case?
Yes, the resultant velocity with respect to that distance along which that resultant velocity is moving.
All right. Thank you, sir.
Okay. Okay. I'm seeing a hand from Francis.
Morning, teacher.
Yes, morning.
My question is also just on the previous explanation, especially for the case of quickest time possible.
Yes.
Yes. So you said when you're calculating time, we take the distance SC and the resultant velocity, right?
Yes.
But then it happens to be that, okay, as our teacher told us that apparently you can also use that distance BA. But for that distance BA, you said you can use the distance BA, but if you use the velocity of VB, that one, that's on it.
If you are finding the quickest time.
If you're finding the quickest time.
The quickest time.
Yeah.
Okay, I think I don't know whether you could try out a number and then you see whether there is any difference.
Yeah, I think I should do that.
So you do that and see whether there is any difference. Then you can let us know.
Okay.
Okay. Okay. Now, this is the case we have. Now here, what is the sweet challenge? The sweet challenge is okay. So they have told that the boat leaves a point on one bank to reach a point 35 meters downstream from its starting point. Now here, one, you don't know whether you are going to use this approach or this side. Now here, what is going to happen? Because they have told you that there are 2 cases here. I want you to understand, because they have told that the boat leaves a point on one bank to reach a point 35 downstream from its starting point. Now you ask yourself, where can I place the 35 meters downstream from its starting point? Someone might say, maybe that is the point. I can place it here. That maybe if this was its starting point, maybe the boat came up to this point. You are not sure about that. Now, when you look at this particular item has good concepts that we need. Number one is going to be about us knowing how do we obtain or how do we utilize the resultant displacement, which is 30, 35. So what do you do? What we are going to do for this particular case, we can come up with our simple sketch. Let me say this. When we come up with this simple sketch, we are going to have our angle. Which angle are we going to have? We are going to have our angle theta, and then we are going to resolve it. So let me say, in case I place my angle, let me say theta along this, it is okay. Then the river will push you towards this side. And then as long as it is 35 meters downwards. So what are you going to do? You are going to write you crossing the river. You are going to summarize your work. And what am I going to start with? I'm going to start with resolving the boat velocity. Resolving the boat velocity. Now, if this is our boat, I've called it VB, and I want to resolve it, I have two things I can resolve it. Now, when you are getting your angle, when you are getting the angle, this angle here, if you place it here, be very careful how you resolve. But now you are going to allow me to be allow me to put this angle to be along the bank, because the best course should be along the bank. So it's going to be here. Now, if this is our boat that is crossing, you could say, now, across the river. If I'm to across the river, what should I have? What about if I'm to go upstream, what should we have? Now, those are the two things that we are going to look. So here, when you resolve it horizontally, let me call it horizontally. Horizontally, you are going to have VB cos of theta. Then what about vertically? What is that velocity for the boat? It's going to be VB sine of theta. Now, those are the two possible ways. Now, vertically, it's when you are going directly like this, like when you have resolved it like this. Horizontally is when you are facing this side. Now, those are the two things that you can have. Now, what happens is that if I come, okay, I'm seeing a hand from Patricia. Yes, Patricia?
Excuse me, sir, I have a question.
Yes.
Sir, I'm seeing, first of all, I'm seeing you're resolving. And yet
Mm.
you're told that's not, that we just use the velocities the way they are. Then also, here when you said at a point 35 meters downstream, it's very confusing because they said quickest time. And my thought quickest time would be on the upstream end.
And that's what we are going. Like, remember, we said that if you are to cross in the quickest time, you are going to move from A towards B. True? And then what will happen? That you are going to be pushed downwards.
Yeah.
Now, but you don't know what the velocity of the boat upstream here if you are to move directly. And now that is what we have as VB sine of theta. Are you getting it?
Yeah, I'm getting hang of it.
Yes. Members, first understand that you have just assumed that this angle is theta. Now, if this angle is theta, what is going to happen? I'm looking at the vertical component, the velocity with which this boat crosses from A to B in the quickest time. Remember, we said that for quickest time, we shall move along A to B. Then the boat will push us downwards. So along A to B, the velocity is going to be VB sine of theta. Members, are we on the same page? Kindly let me know. Have you understood that? Because I'm going to use it going forward. So now we are going to proceed. Now, as we proceed, okay, so So vertically, we shall have VB sine theta. Then if it is moving along horizontal, it is cos theta, because we are not sure at what angle was it steered at. So that is what I wanted you. Remember, I could not put it here because this is the resultant. Please take note of that. Then what about, remember our current going down here is going to be 3 meters per second. That is the current of the water. But this VB of ours, we have it because they told us that the velocity, the speed, in fact, they used speed. The speed of the boat was 2.5. So this is going to be 2.5 sine of theta. Now, in case I want to get the actual velocity downwards, what am I going to say? So I'm going to come here and say actual actual downstream velocity. What is it equal to? So if I want to get the velocity downstream, members, what is going to be our velocity downstream? Could someone tell us in the chat? Downstream, I want you to look at the two velocities. That downstream, this is your water, and this is the velocity of the boat. So what is going to be our velocity? What is going to be the velocity downstream? Can you try in the chat? Hey. What is going to be now the total? Now we are going to combine the one for the boat and then the one for the water. So what are we going to have? Okay. Let me see whether I can pick a hand from Cliff and then Chomi.
Yeah, so teacher, according to that, the total velocity downstream will be V water minus VB sine the angle.
Okay, can you tell why are you saying minus?
It is minus because the V of the water is moving downstream, and the V, there is the resolved component, the VB sine theta, is moving upstream. So, but since the resultant should be moving downward, we realize that we shall have to subtract the VB from the V water because they are in different directions.
Okay, repeat that.
The reason as to why we are subtracting is that at the end of the scenario, we are realizing that our boat is moving downstream. Therefore, the V of the water is greater than this one moving up, the one we have resolved, the VB sine theta. It is moving upstream, yet the V of the water is moving downstream. So since they are in different direction, we shall subtract the VB sine theta from the V water.
Okay, thank you. Yes, now members, so here we are going to have 3 minus 2.5 sine of theta. Why are we subtracting? Because the water is greater than the 2.5 sine theta. That's why we are making the subtraction. Okay, now that is the V downstream. Now, what next? I'm going to continue and then we continue breaking our item. Now, okay. Now, in case I want to obtain, because remember the question is talking about what? It's talking about time. Now, if the boat must land 35 meters downstream, what do you need to know? You know very well that distance is equal to speed times time. Now, what is your distance? Your distance is 35. What is this? The velocity downstream? This is now velocity downstream. So your velocity can be the 3 minus the 2.5 sine of theta, the resultant velocity downstream, then times your time, which is t. But here, when you look at it, you notice, what is that one thing you notice? You notice that you do not have your time. So you need to find the time. How are you going to find the time? Now, to be able to find the time, you can come and say that distance is equal to speed times time. And what is the distance you wanted to cross was along AB. That was the distance that we wanted to cross. So since crossing the river is 2.5 cos theta, we can now come from this kind of relation, and then we get what? We get the time. After obtaining the time, we come back and substitute in that particular equation. Members, are we still on the same page or we are not? I want to know through the chat. Are we on the same page up to that point? Not yet. People are saying not yet. Okay, allow me to repeat a bit. Allow me to repeat a bit. Now, we have said that we are crossing a river, but we want to use the quickest time. Are you seeing this? This is your point A, and this is your point B. So we say that in the quickest time, what do? We cross the river like this. This is like your boat. But when you are crossing this river, what happens? That this river will push you. And we say that this is going to be our resultant. Like our resultant. So now, if you want to get, you could say, because here, you could say that if this is what you want, you ask yourself, what is going to happen? This is your river. And if, I don't want to use this angle. Okay, this is my angle theta. Let me use that one as my angle theta. Now, what is going to happen is what? What happens that this river here pushes you back here, but you don't know which angle you must steer at, such that you can reach in the quickest time possible. Because you don't know that angle, now that's why we go on to resolve. Now, when you look at our diagram here, we are trying to find out at what angle should you steer. When we talk about the course, we are mainly looking at the angle. Because they have told that you have two possible courses in crossing the river, and the best would be where least time is taken. Now, personally, I've first taken on this to find out if I go like this, which one would take the least time? Now, if you are to go direct like this, the river, but I was interested in finding that angle. Now. Maybe let me first pick a hand, and maybe if you have picked something, kindly you can raise up the hand, and then maybe you explain to the members as well. Yes, Patricia.
So I think what's disturbing people is the fact that they said 35 meters downstream, and yet people had mastered that for the shortest time possible, you take the upstream path, and also on the part of the velocity that you used, the resultant velocity, subtracting 3 from 2.5 sine theta, like how exactly it comes about, and like how it makes sense for it to be the velocity we are now using to multiply by the time to multiply by a time to get the distance and all that. So people are confused in that area of 3 minus 2.5 sine theta. Why it's like that? Like, why don't we use the velocity of the one that they use in that, like the resultant that they use in the one of the shortest time, the one that you had showed us the other side of VB squared plus VW squared. But now we are going on to use 3 minus 2.5 sine theta. So I think that's where the misconception is.
Okay. For you, what have you understood? Maybe you could throw more light.
For me, honestly, sir, I'm also in the people that are not confused, but I'm just pointing out where they're exactly confused.
Okay. Thank you. Okay. Now, when we talk about, yes, come in.
Yes, good morning, sir.
Morning.
I think where people are confusing is, first of all, why are you resolving the velocity of the boat? That's the first thing that is confusing us.
And then also,
Okay.
yes, how are you resolving the velocity of the downstream? What are you doing? How are you doing it?
Okay. Now, why are we resolving? When you look at the question told you that the crew had two possible courses in crossing the river. When you talk about the courses, remember I have told you that when you are crossing the river, you can go like this or you could go directly like that. Those are the two courses you can use. But each of them will lead you to your destination. Now, here they are telling us that we have two possible courses of crossing. Now, when I look at the two possible crosses, I have this is one of them. But when you look at this one, I don't know the course which is fitter, the angle at which I must move on. Because when you are moving, someone, let me say this is your river. Someone can move like this, someone can move like this, someone can move like this. I don't know whether now that is okay why we are resolving. Because you don't know the angle at which you must move at. Is that fine? Not yet. Oh, I'm not getting. Francis and Moses?
Excuse me, sir.
Yes.
Teacher, for me, why you lost me, is that at some point here you're explaining the first normal situation of the quickest time possible, where you first go straight. Now that's why I had you, because the question they're talking about 35 meters downstream, and I thought downstream means like going down from your original point vertically. So that one was making sense. But now where I lost you is that you now decided to leave that one alone, that path alone, and then you come to this other one.
Oh,
which
now,
doesn't exactly, yeah.
Okay, come again.
Well, like at first I was understanding you when you're using the original sense that when you're getting the quickest time possible, or even the word, the mere fact the word downstream, it means distance downwards from the vertical position you're in.
Yeah.
Now, for example, B going downwards, that one. Yes. So I thought you're gonna use that second case that you used, then you calculate for the theta for that case, and theta will be the angle. Yes, but then I saw you somehow you switched up to this other path, which now kind of confused me.
Okay. Was the resolving okay?
Yeah, the resolving was okay.
Was this resultant okay?
Yes, that resultant was okay.
Okay. I think let me now start from there. Now. Okay. Now, when you look at the okay, let me come back here. Now, when you look at the situation where we are, we hope this was also okay when we are finding the distance, because they told that this distance here, let me say this was what we are assuming as 35 downstream. Now, if that is the 35, that is your distance, and then the velocity to achieve it, the resultant velocity, that's what we obtain, then times the time. Now, what next is you need to ask yourself, what time can be taken for us to be able to cross that river? Now, this item here has two approaches that we can use. One of the approaches is using the time, like the other normal way, like how I was showing you. That is one approach. The second approach is using the angle approach. Two approaches can lead you to the same answer. Now, since the boat has to travel 50 meters across the river, you are going to ask yourself, what time has this boat taken when it is traveling? So in order for you to get the time taken by the boat to travel, I'm going to come here and say that still distance is going to be my velocity times the time. But what is the velocity the boat is using to, what distance is the boat supposed to take? That is supposed to be 50. And what velocity is that? That's going to be 2.5 cos of theta, then times the time. So what is our time? It means that our time is going to be 50 divided by 2.5 cos of theta. Now, when you divide, you'll have your 50 divided by 2.5, which will give us now our time equals to 20 divided by cos of theta. Now, this is the time we are going to have. But already, since we have already obtained our relation that 35 will equal to 3 minus 2.5. It was sine of theta, then time was our time. So what can we do? Where there is t, we are going to substitute our value. So we can have this as 35 equaling to 3 minus 2.5 sine of theta, then times time, which is 20 cos of theta. So here we are going to do our mathematics. So when we do the math, I can multiply through by cos theta, so I get 35 cos of theta equaling to 3 minus 2.5 sine of theta. Then I have my 20 in there. I'll multiply this by 20. So this is going to be 35 cos of theta equaling to 60 minus 2.5 times the 20, you end up with 50 sine of theta. Now, what can you do? Now, what you can do here, you can solve using any approach of your choice. Since you have the cos and the sines, I can solve using any of the two. So if I'm to use the two, someone may decide to square both sides. So you can square this side and then you square this side. So when you square, what will you have? We shall have 35 squared, which is 1225 cos squared of theta, equaling to the square of this side, that is 60 squared, which is going to give us 3600. Then minus, you have 60 times 50 times 2, which is going to give us 6,000 of sine of theta. Then that is plus 50 squared, which is going to give us 2,500 sine of squared theta. So then you are going to collect like terms and then express cos squared theta in terms of sine squared theta. So this is going to be 1 minus sine squared theta is equal to this. So when you collect like terms, you are going to have 2,500 plus 1225. It's going to be 3725 sine squared of theta minus 6,000 sine of theta. Then when you take this one the other side, it's going to be 3600 minus 1225, which is going to give you your answer here as 2375 equals to 0. So when you solve this, allow me to use you solve it. Let me solve it and we see what we get. So when we solve it, I have 3725 negative 6,000 and then 2375. When I solve it, I'll have my sine theta equaling to 0.9104. Then the other one, sine of theta, will equal to 0.7003. And when you go on to get the values, sine inverse of 0.9104, you'll get your answer. You'll get what? You'll get your answer here as theta equals to 65.56 degrees. Then the other theta would be sine inverse of 0.7003, which is 44.45 degrees. Now, these are the possible two courses you can steer the boat. Now, after you steering the boat, you ask yourself, which one will give me the quickest time possible? Now, for the quickest time possible, you come back here and substitute. That when you put in, let me say 20 course of maybe 65.56, you'll find yourself getting 20 divided by course of 65.56, when it is about 48.3395 seconds. When you use 20 divided by cos of 44.45, you find yourself getting your answer for T as 28.01. This is 6. Okay, this is what? 7 seconds. Now, that is how you do it a bit in case you have decided to get the course. But like I've said, there are two approaches we can use. There are two approaches we can use. The second approach is using the time. If I'm to use the time approach, I can use it also to get the same answer. But if you want, I think, could you try out? I've not tried the approach because here they wanted you mainly to use the course because the question, since it was specific that the crew had two possible courses, it means that you needed to show how those two courses come about instead of just you using the direct, like the other direct approach that we know. But since they told here, they wanted you to use these possible courses to prove which one will give you the least time. So when you are moving, you'll find out that this one, where we have got our answer as the 60, was it 65? This was this one. Then this side, where you got your answer as least, it was when you use the other approach. So I don't know whether people have picked something or it is. So you could raise up the hand and then you share a bit. I want to pick. Yes, Esther?
Good morning, teacher.
Yes, good morning.
My question is, why are we using the time for AB that's as the same time for the 35?
For the 30? Now, the boat has to travel 50 meters, not so?
Yes.
And what is its velocity? Its velocity is going to be the 2.5 cos of theta.
Yes. Sine theta.
So yes, that's why we are using it. Because what happens that when the boat is, let me say it is traveling along the direction of theta, it means we shall have our cos of theta, because I told that we have two velocities here. We have the velocity across the river. The velocity across the river, when you resolve like this, you'll have your boat in terms of u cos of theta. Now this velocity here, because when your boat is traveling across the river, what does it mean? It means that this is the velocity it's going to be possessing. As it is traveling, it is going with the water. So that's why we are using it. Then the 2.5 sine theta is the component upstream.
Okay.
Okay, I think Atwine and then Vida.
Yes, thank you, sir, for the opportunity. Now, for me, my question was that you said there are two approaches. I was like asking on that second approach, do we use like the case 2 where we find like the shortest time, or case 3 where we find at a given point, or we mix them?
Oh, now here, since they wanted us to prove for the two possible courses, here you like they were indirectly asking you to check for shortest time and then the quickest time. So they were asking two parts in one.
Oh, so like it was case 2 and case 3.
All of them inside the same thing.
Okay, thank you, sir.
Like when you look at, let me say, this is your angle theta. What happens that this was your 2.5 water when the boat was trying. Now upstream here, for your quickest time, it would be 2.5 sine of theta. This is upstream when you are da. Then along here is what we call now across the river. Across the river, it is 2.5 cos of theta.
Okay, sir, thank you.
Okay. Yes, Vida and Bruce.
Good morning,
Vida.
sir.
Yes, good morning.
Sir, I've understood, but my worry is still here. Clarifying more about actual downstream velocity. Why we subtract 2.5 sine theta?
Now, okay. Vida, you tell me you have someone who is 50 kilograms, and we have another one who is 20 kilograms, maybe, and you are on a horizontal thing, eh? On that, okay, no, let me use actual things. Vida, are you seeing this? Are you seeing this?
Yes.
What is your resultant here? What is going to be your resultant? Let me just put here something like that.
It is 5.
It is 5. How did you get 5?
You subtract 10 minus 5.
Now, why do you subtract?
Because 10 is greater than 5 and the resultant is in the direction of 10 newtons.
Now, still here, when it comes along for the velocity, what happens is that you are trying to go this side as a person. This is VB sine theta. And then there is someone coming like this side. What happens is that this person is going to push you. If this person pushes you like this, it means that this person is heavier than you. This VB sine theta. Now, this negative is the one that shows us that this speed of water or the velocity of water is heavier than the velocity with which the boat moves along. I don't know whether you are getting it.
I'm getting it, sir.
So that's why we are subtracting.
Okay. Okay, thank you, sir.
Yes. So what happens is that one thing now you need to know is that if just imagine you are walking at a speed of 3 meters. Let me use this, 3 meters per second. And then maybe someone is moving like this. The moment this person pushes you, your total velocity doesn't, let me say you're moving up here, let me say with 1 meter per second, and this is 3 meters per second. Now, if this person pushes you, your velocity, your total velocity doesn't become 3 plus 4. Like your velocity doesn't increase, but instead it reduces. I don't know whether now that one can make a bit better. Okay. Then the last one. Yes.
When I'm obtaining that angle theta.
Yes.
We have cos and sine, and the angle is the same. But if I don't want to square and I just use the R formula, do I get the same answer?
Yes, you get the same answer, whether you have used R formula, whether you have used the T formula. Whatever formula you use, you get the same answer.
Okay, thank you.
Okay. So you can take a screenshot of this. Take a screenshot of this. Yeah. And also, I think that you could take a screenshot of that. Yeah, but also I sent you more items. Okay. Yeah. So allow me that we end here. Allow me that we end here. So we shall start from here.
Thank you, teacher.
Yeah, I think someone is saying that we need to revise more. Let me hope, Joan, you have understood now why we subtract. Julie, let me hope that is okay, why we have subtracted. Yes, it is for. Yes, the reason, members, let me hope, I think I've tried to explain why we subtract. Why we subtract is that when you are moving up and someone pushes you, your speed does not reduce. Your speed is not going to reduce. Your speed is not going to increase. So addition shows that something is increasing. Subtraction, it means something is reducing. Okay. So have a good day.